The analysis of the graph is still continuing. Okay, all right. Please make sure that you watch the first video. Now there are three videos. There's a first one that is about the plotting of the sine function without using a calculator. The second one is the first analysis, and this one is the second analysis. And we're just moving forward. We want to build and we want to create a strong background and foundation of trigonometric graphs. So yeah, let us move here. Right, we know that we have said that y is equals to a into sine bx. Okay, now I want us to look to these two values, this value here and this value here, and what do they mean. A value, okay, fine, right, and let us just write them here. So a value here will present two things which are very important. The first thing will present the shape. A value will look at the shape of the function of the graph. The function of the graph. What does that mean? I will look at the function of the graph. All right. Let us see how does that mean. All right. Now let us show. We said that A present the shape of the graph is just the shape here, not the shape, the shape of the graph. So if A is positive, A being greater than 0, the graph will take this shape, and across this period, the graph will thereby end to this, like this side. Is it careful? So this is because A is greater than 0. But if A is lesser than 0, things changes. Now, A being lesser than 0 will simply change the thing. Others will change. So, if now A is greater than 0, this will be the shape. We'll start down here and will end up. So this is what simple A do. He just twist the ups and down, the shape of the graph. He just like as if the graph is reflecting, just up and down, just up and down, just up and down. If A is negative, the graph is up. If A is positive, the graph start up then and down. If A is less than 0, the graph start down and then end up. That is the thing that A do. Okay, presents the how the graph will start, the shape of the graph. Okay, but that is not the only thing that A can do. The second thing that A can do, A can also is I want to call it is a response, responsiveness of the graph. All right, I nailed it. Give me the round of applause there. So it's just how the graph has become responsible into the stretching, the up and down stretching. So the up and down stretching of the graph. What does that mean? Let us put on the practical course now. Let us just put it on the practical course. Okay. So we say that A present a shape of the graph. I've done with that one. And secondly, A is a stretch up and down over the graph. So let us recall what we have been what we have done previously, saying that if x is 0, we said that this graph 1 will be just 0. And if x is 90, remember now it's the graph is just being positive here, and we can just come back here and look that the graph is positive here. So it's 90 is equals to 1. We remember that one, so we just plot 1. Okay, and we just plot 0 again. So now let us draw the graph. So here's my graph here, and here we have 0 here, and here we have 90 degrees, and here we have 180 degrees here. So here is the thing that we want to check, right? Is that we want to put this one, we call it is a stretch on the graph. Okay, So now let us say our graph is times by 2. Meaning now my graph will be equals to 2 sine x. Because this multiplied the entire graph, it just changes these values here. It multiplied the values of y. It multiplies the values of y. So regardless, or then we know that if 2 multiplies 0, 0, nothing will change. But if 2 happens to multiply this one here, which is in a which is allocated to this point and this point, it will change this. Okay, I'm having one here. How that will change? We will see that here, if I say 0 times 2, I get 0. So there is no movement in 0. If I say 2 times 1, there is 2. So there is a movement here. It's a stretch up. The graph is stretching up at 2. If I say 2 times 0 again, I got 0. So there is no movement here. Okay, now let us explain this on a clear slide. Okay, that was what we have done before. If you can just look through this video, you can see that this one was that one. So I'm just taking it from 0 to 206. I just selected this part because I have a space here, a short space. So we can see I said this one, remember that I said the value of A present the shape of the graph, but now we are looking at the value of A presenting the stretch up and down, the responsitiveness of the function, right? How does the function, the entire function, respond into the multiplication or the division of each one? So into any coefficient that or to the coefficient that multiply the entire function. All right, so if now the function has multiplied by 2, what is happening here will happen. We say that only the values at the will be moved, will be affected. Only the values at the minimum and the maximum point, only the values we say, the values at 0 will not be affected, such that the graph here will just go, such that the graph here will just be like going up, but come back to its point also. And the graph, remember, it is multiplied by 2, the graph is like going extremely down here and come back at 2. So you can see that the graph is being stretched by 2 here. The graph is being stretched by 2. So because the graph is multiplied, it stretches the graph up and down. But what if the graph is being divided by 2? So if the graph is being divided by 2, this will be simple. The graph won't move to its original point here, because that one is just moving the graph, is just stretching the graph up and down, but not moving them to their intercept. So the graph is still allocated. It's just being moved to its minimum and maximum and any values beyond that. But at 0, the graph is nothing. I've shown that one on the is on earlier before. I've shown that by multiplying with the outcomes with the output, which was 0, 1, and 2. So now the graph will just stick, because if you divide any number divided by 0 is just 0. But if you divide 1 by 2, the answer is at a half. So now the graph will go like this one, but go back at its 0 in 180 degrees and go like this one, right? But go back here. So you can see that here we have the point is 2 here. Now the graph is divided, is moved down. The graph is divided, is moved down, is pulled, or is a pulling, but I don't want to say it's a pulling before, because that introduce the movement, the one that we are going to be discussing. But this one is just the shrinking of the graph. The graph is being shrink, the graph is being stretched. It's a shrinking and stretching of the graph. So yes, that is how it goes. And this one here, it represents y equals to 1 over 2 sine x, and this one here on the other side represent y equals to 2 sine x, and the original which we saw, the original which represented y is equals to sine x. So this one is the other property of the graph. Thank you very much, and wait for the next video.